This presentation will explain how to enter the dimensional data into the MPS566 GNSS receiver to ensure precise navigation from a closely coupled GNSS and inertial navigation system. There is a MPS566 Pilot installation guide in PDF format that covers all these tasks plus more. Please read it. I will explain the measure up of the relative position of the two GNSS antenna on the compass deck and the dimensions from the position antenna to the MPS566, which is located in the wheelhouse. This picture shows the GNSS antennas up on the compass deck. The one close by is on the port side and is what we call the position antenna. The antenna over on the starboard side is the heading antenna. If you can't place antennas exactly port and starboard, then place them parallel to the center line of the vessel in a bow-stern direction, parallel to the vessel center line. In today's example, the GNSS position antenna is on the port side and the GNSS heading antenna is on the starboard side. That is, they create a baseline exactly at right angles to the vessel center line. We use a tape measure and measure between them in a positive Y direction, and we note that they're the same height on the vessel. While up on the compass deck, measure from the position antenna to the MPS 566 in the wheelhouse. Measure in the port starboard axis, positive Y going to starboard. Measure the forward aft axis, positive X axis going forward, and the downward axis, the Z axis. Now in the wheelhouse, you will have screwed the MPS 566 Pilot system down firmly, either facing forward to the bow, which is the default as shown on the diagram on the right side, as well as the actual photo in the top left, or facing stern as shown on the left side of the diagram. In today's example, the MPS 566 is facing to the bow, which is the positive X axis. We can now start entering data into the MPS 566 via the web user interface. While we were on the compass deck, we used the tape and measured 11.08 meters between the two antennas. The first task is to double check this critical measurement between the two antennas. So we can let the MPS 566 measure this vector precisely between the antennas by ensuring the INS function is off and then looking at the receiver status vector. So we do that by going to the receiver configuration, INS, and ensure that this is not ticked on. Then we just go to the receiver status and the vector heading display, and down at the bottom right you'll see the range between the two antennas. This is 11.08, which confirms the taped measurement. So we go back to the receiver configuration and back to the INS menu, and this time we're going to tick it on and go through the menus. So turn that on. Under General, leave the default values on and the receiver motion as marine. Under Graphic Prerequisites, there's no need to change anything. These values really only change the shape and the size of the boat in the 3D view over on the right. They don't affect the accuracy of the GNSS data. Mounting angles, no need to input the orientation of the MPS 566 in this example, since the default orientation is used. In other words, the receiver is facing forward, is facing the bow. GNSS lever arm. Under GNSS lever arm, leave this first set of data reference to primary GNSS offset as 0, as we want the NEMA messages to be referenced from the position antenna. In the primary to secondary GNSS baseline, in other words from the position antenna on the port side to the heading antenna on the starboard side, we will enter 11.08 meters in the positive Y axis. Also leave this accuracy measurement to 1 centimeter. That's quite critical. Now go to the IMU lever arm from the reference point to the IMU. In other words, from the GNSS antenna and position antenna to the bullseye on top of the MPS566. Here is an example. Here's a photo of the bullseye on the top of the MPS566 where we're measuring to. In this example, we're going to enter the X value. This is the forward and aft distance. So let's say the MPS566 is 3 meters behind the position antenna, so that'll be minus 3 meters. And let's say the MPS566, which is down in the wheelhouse, is starboard of the position antenna, which by say 5.54 meters. Z is the vertical distance from the GA830 antenna to the MPS566. In this example, its tape measurement is 4 meters down. Make sure to add 9 centimeters to the Z measurement, as the antenna phase center is 9 centimeters above the base of the antenna as shown. So the Z measurement in this example is now 4.09 meters. NEMA messages are output at the antenna phase position, so that's why you have to add the 9 centimeters. Enter 4.09 Z. You don't have to alter anything in the heave filter. Press OK to accept all these configurations. Then press this OK. Now it should take about 20 seconds to initialize and deliver precise heading and rate of change, etc. You can check how it's going by going to the receiver status menu and then the INS status page, and you'll see it's actually aligned. If it's aligned, so it usually is within 20 seconds. If it doesn't align and it stays degraded, then go back into the receiver configuration INS page and check that the most critical check is the distance between the two antennas. Here it's 11.08, and make sure that you put 1 sigma of 1 centimeter as the sigma reading in there. The other thing we recommend is that you look at this 3D, make use of this 3D graphics page, and here you'll see the heading antenna, the position antenna, and the MPS566, and you can spin it round and check that they're in the right orientation. Yes, the MPS566 is about 4 meters below the baseline of the antennas. Don't worry about the shape of this boat, it's just an indication of where bow and stern is. The inputs we have been through mean the system is producing precise position, rate of turn and other data, as well as heading of the vessel. When a pilot comes on board with their Pilot app, they need the dimensions of the position antenna relative to the vessel's hull. The following measurements are needed from the GA830 GNSS position antenna to the bow, to the stern, to the port side of the vessel, to the starboard side of the vessel. The vertical distance from the antenna to the keel of the vessel. Remember to add the 9 centimeters. No further measure up is needed for the angle of the relative bearing between the two antennas. This is already handled in the prior measure up and input to the MPS566. The NEMA data from the MPS566 is already the heading of the center line of the vessel. There is no need to measure the position of the AIS antenna. There is a full installation guide for the system, and for further support contact the Trimble Marine dealer that you purchased the system from, or visit the marine section in trimble.com, or visit wtemarine.com.